For message 1. It receives from its own interface. Received a 0. But it has to add its own. Then it is 1 away from the root bridge. Further down there are other equipment. It sends out 1. Its own interface is 1 plus 1. It is 2 away from the root bridge. Okay. You need to understand these parameters. Because wait, we're going to compare them. Then we officially start talking about some other election content. Before we compare these 4 parameters, I want to emphasize. If STP is to conduct roll election, our first step should be to choose the root. An environment Reagan must be the most important. Like a tree. The roots are the most important. So let's choose the root bridge first. That is, the order of our election is root first. After selecting the root, select the root port. After selecting the root port, select the designated port. Then the rest. Not a designated port. Also those ports that are not root ports will be blocked automatically. That is to say, I will not allow this interface to forward business traffic. Actually, the core concept of STP is to block ports. But STP does not just randomly pick a port and block it. It has to calculate first. After the calculation, the role is determined. The last remaining ports are blocked. So this is a core idea of STP. What is the root? What is a designated port? Let's talk slowly. First we have to choose the root bridge. This is the first step. So how to choose a root bridge? I just said. All elections will be based on the packets sent by the device. Then the first step is when we conduct elections. Everyone must first know. The equipment on the second floor is actually incompatible with each other. For us, each switch only needs to start STP. It will consider itself the root. When you reach the NP stage, you will learn the specific packets of OSPF. Everyone knows that. Many agreements in the third layer are relatively modest. They don't think they have roles. But in STP they all think they are the root. It is now about to send a message to the outside world. Which parameter in the sent message will be filled with itself? Since it considers itself root, it will send out BPTU packets. Then this will fill it in. They start exchanging messages with each other. But the message exchanged between them is not called a loop. We will learn a lot of protocols in the future. In the protocol, various devices exchange messages with each other. They are not generated loops. The loop generally refers to the when a data is sent. This is a user's business data. It's a pretty standard ring. Now in this network, if passed like this is called a loop. However, the packets exchanged between devices are limited. Especially when the devices are all released at the beginning. The process is limited. And soon the interaction is over. This is not called a loop. They have to think of themselves as a bridge. Both fill themselves. The device thinks it is rooted. Will the devices all receive messages from each other? That is, prove that device A, device B, and device C can receive messages from other devices. They are interconnected 2 by 2. Then after receiving, they compare some parameters to determine who is the root. We will first compare the bridge ID of the root. So what does this parameter consist of? It must identify the ID number of the device inside. That is, it identifies its identity. So what is its composition? It is prioritized by 16 bits. Backplane MAC with 48-bit switch. Now many switches have no MAC address under the interface. In the early days, there were MACs under the switch interface. Each manufacturer is different. But now the second layer switch basically only has one backplane MAC. There is no MAC under the interface. That is to say, now this device has a MAC address. Then it will first use this MAC address, plus its current priority. Then to compare. This priority has a default value of. The default is 32768. Many parameters in the second layer default to this value. Everyone can understand. We can manually configure. I tell you this. If now there are 3 devices, the priority and the bridge ID of each device, all are by default. Then the MAC of the switch will start to compare. Among them, the smaller the MAC address, the better. So, first select the root bridge and compare the bridge ID. The smaller the parameter, the better. If we compare the priorities when we compare the results, we don't need to care about the MAC of the switch behind. So we are often in reality. The priority will be modified manually. That is, we can reduce some of the priorities. We do recommend that you manually specify the root bridge in the online network. Prevent misconnection and root grabbing. Because the root bridge is preemptible. You will learn some protection of BPTU in NP in the future. Then you will know the content. I give a simple example. Now there is a switch plugged in. If the priority of the device is all 32768. No modification. Originally it was the root. If it is connected now its priority. For example, it is 4096. Then it will take away the position of the original root bridge. It is no longer root. The location of the root bridge is taken away. Which means that the entire network topology will change. You should know. After the entire network topology is stable, BPDU packets will only be sent by the root bridge. Originally, the topology we maintain is that it is the root. Suddenly a device came in. It took the place of the root. Then the topology as a whole will change. Including what each device thinks is root has changed. It will have a considerable part of the time. It will bring some corresponding problems to the business. This is a matter of root priority. So we manually lower the priority of what you want it to be. The root bridge can be specified as 0. In the whole environment, we usually change to first set a 0 and set another 4096. You may find it strange. The priority must be configured as a multiple of 4096. So say the minimum value is 0. The second smallest value is 4096. When we configure a root bridge for it. Then configure a backup root bridge for it. The backup root bridge is when one day the root with priority 0 has a problem. Then the priority is 4096 to become the root. Generally speaking, suppose there are multiple devices in the environment. For example, this device performs best. I give it a configuration priority of 0. This device is the next best. I configure it to 4096. The two devices are 32768. By default, the first round of election compares the priority. We don't look at the MAC address. Compare priority. It sure is the best. Then it is the root. If it's gone, then it is the root. Not so performant, these devices will never be rooted. Certainly. If it's gone, then there's no way. We usually have to change equipment. It's enough for everyone to know this. Then we're done choosing the root bridge. There will only be one root bridge. Do you think there may be 2 root bridges? Some students may ask. Will these parameters not compare? It won't. Because we learned before. MAC address is globally unique. MAC address will not be repeated. So we must be able to compare. So there is no doubt that the parameters of the root bridge comparison are simple. Just these two parameters. A comparison will come out the result. In addition, we manually changed the switch backplane MAC to the same. Reboot next time. MAC address changed back again. It cannot be permanently modified. The MAC address is used as a hardware address and physical address of the device. It cannot be permanently modified. Everyone should know this. It is a physical address engraved in the chip of the network card. We also call it the hardware address. You can't configure fundamentally modifying the hardware of the device. This is the same as the bandwidth we changed before. A 10 megabit interface. A 100 M interface. You change it to gigabit. It's not a gigabit interface either. Physical parameters cannot be permanently modified. This is the first step.